Hello everyone. Today we are going to talk about bipolar junction transistors, normally called as transistors, and we are going to do work on the NPN type of transistors. Okay, transistors look like this normally. So they can be covered with metallic substance, or they could be covered in a plastic casing or something like that, which is this one, which you can see on screen. It has three pins. One is called as base, second is emitter, third is collector. Now, which one is the base or which is emitter, which is collector depends on transistors. They are not at the same position everywhere. So, if you need to figure out which one is the base, emitter, or collector, you need to go and check the data sheet of that particular transistor. So, for example, this is BC548. So, just Google it, BC548 data sheet. It will show you the sheet, it will show you the diagram, it will show you which one is the base and which is the emitter, which is the connector. In Tinkercad, it is basically identified, so you don't need to worry about that there in Tinkercad. So let's work on transistors. Any transistor acts like switches and amplifiers. So we'll work on this switches and amplifiers thing now. There are two diagrams that I'm showing you. The one on the right is a diode, a simple diode. The one on the left is a transistor. Let us consider the diode first. The diode has a positive point, positive terminal, and a negative terminal, and we normally connect them like this. And when they are connected properly, the current passes through. And if you reverse this the negative up and positive down, and you do not connect it properly, which is called as reverse bias. If you remember, we did it in one of the classes. So if it is reverse bias, the current doesn't pass through. So either the current passes through or the current does not pass through. So that is the diode. What about the transistor? In the transistor, there are three legs of a transistor. Okay? And if you see this vertical line in the middle, there are three wires coming out of this particular part, and one is perpendicular. The one which is perpendicular to that plate is the base, and there are two wires at an angle. So one of them has an arrow, other one does not have an arrow. The one that has an arrow is called as the emitter, and then the one which is does not have an arrow is the collector. I've also written at the bottom that the base is always positive, collector is always positive, emitter is always negative. So that means you always have to connect the collector to the positive part of the battery or the circuit, emitter to the negative part of the circuit. So the current will pass from the collector to the emitter always. Now, when the diode is connected properly, it will always allow the current to pass through. But in that is not the case in case of a collector emitter. The collector emitter works like a diode, yes. If you connect them in reverse, that is negative up and positive down, it will not work at all. But when you connect it with positive on the collector and negative on the emitter, it will still not pass any electricity. And electricity will pass only if you pass a little amount of electricity on the base. So that means you supply a little amount of electricity at the base that will allow the current to pass from the collector to the emitter. The moment you switch off the electricity on the base, the collector emitter electricity will stop the flow. So that means this base works like a gate. This base works like a gate. So if this base has no electricity, collector emitter electricity does not pass through, and this whatever is existing in this particular circuit is a closed circuit, sorry, in an open circuit. So that means nothing passes through. All right. Now let me show you the circuit on the left hand side. On the left hand side, this is the transistor, And the transistor has the base on the left hand side and the collector on top and the emitter at the bottom. And you can see that the collector is connected to the positive side of the battery through a load. Now, if electricity is passing from the collector to the emitter, naturally it has to pass through the load also. And the load will be activated. The load will get electricity because the electricity is passing through the load. But if nothing is passing from the collector to the emitter, this load is not going to get any electricity. Okay, so you notice now that the collector is connected to the positive side of the battery, the emitter is connected to the negative side of the battery. Now the base is getting some voltage from this small battery over here. And this small battery is connected through to the base using a switch and a resistance. So when the switch is closed, base gets electricity. Current passes from the collector to the emitter and the load gets the electricity. You can see when the switch is closed, the load gets switched on, and when the switch is open, the load is there is nothing passing through the load and it is not working. Now this whole circuit on the left hand side is equivalent to writing the right side of this right side wala circuit. So this circuit has a normal switch and a load and a battery. So when a switch is closed, the load gets electricity. When the switch is open, the load does not get electricity. Now you saw that we are basically using a switch which is a physical switch, like a normal switch that we have, the push button switch kind of a thing. Uh, Normally in a circuit, when we use it like a switch, we do not use a physical switch. Although in the example that I am going to show you, we will be using a physical switch, but later on we'll be doing it through Arduino also. So what happens then? This same right hand side switch thing is basically using a switch. The load gets electricity or does not get electricity on the left hand side. Using the switch, using the transistor, the electricity passes through the load or does not pass through the load. Now, how much voltage is basically required at the base? It requires a very less voltage, even less than 1 volt. It requires as less as 0.7 volt. So when you pass electricity, a small amount of electricity at the base, it will allow a large amount of electricity to pass through the collector emitter. This is a similar kind of a circuit, but we over here we actually use the physical switch. Over here I'm using Arduino to generate a high or a low. If you see on the left hand side, a high which is a 1, it basically is 5 volts, and a 0 which is a low is 0 volts. So when I pass a high to this part of this circuit through the resistance to the base, so that means I am passing 5 volts to the base. So when I am passing 5 volts to the base, what happens then? The collector emitter gate opens and the current passes through. So that means you can see the battery on the right hand side is a 24 volts battery. On the left hand side is just 5 volts or 0 volt, right? So 24 volts passes through the lamp, which is the load over here, through the collector, through the emitter, gone down to the ground now. So if the switch is on, that means a high is being passed, then the base will get electricity, collector emitter gates open, and the current will pass from the positive side through the lamp, through the collector, through the emitter to the ground, to the negative side of the battery. And if nothing is passed on to the base, if it is 0 volts, then nothing happens. The lamp does not get electricity. Why? Because there is nothing passing. This gate is closed, so current is not passing through. So there is nothing passing through the lamp also. This is the same thing in action. It is showing a 0 and a 1 on the left side. So when a 1 is being passed, the lamp is on, and when a 0 is being passed, the lamp is off. Okay, now I am going to show you the NPN transistor at work. So what I did was I searched for transistor on the in the search bar over here and selected the one with the N on top. This is basically the NPN transistor. And when you see this transistor is it shows here as NPN transistor BJT, and it shows that this is the collector, this is the base, this is the emitter. But when you get the actual transistor in front of you, you need to go and check the data sheets to figure out which one is which. All right. So how do we work on this? We need a few things. Uh, we need a battery. Uh, we need an art. Okay, we will not use an Arduino. We'll use a breadboard. All right. What else do we need? What do we put here as a load? Let us put an LED as a load. And of course, we'll use a transistor, sorry, a resistance. All right. Okay. We need a small battery on the left hand side. This is the battery which is basically the one which is going to be giving the voltage to the base now. Okay. And the battery in the right hand side, which is a 9-volt battery, is what is going to work on the load. All right. And we need a switch to switch the thing on and off. So I think whatever we need, we have it here. What we need to do now is from the positive side, so let's not connect it like this because otherwise it will be short circuiting. Alright, so where do we connect the negative? I told you that the negative is to be connected to the emitter. Okay, so let's connect the negative to the emitter and let's make it black. Let's connect the positive through the load. So this is positive through the load to the collector. So we have connected the battery. Let me just put an mirror image of that. So fine, it's connected. Fine, connected now. Now we need to connect this battery to the base. So I have this part of the battery to the base and this positive to the other part of the switch. So that means now the positive from this battery is going through the switch to the base. The negative of both the batteries should be connected together. I told you if you have two circuits and both of them are having different batteries, the negative of both the batteries should be the ground of both the batteries are supposed to be connected together. So let's see the circuit how we have done it. On the right hand side is the load battery. On the left hand side is the controlling battery. Okay. So this battery basically controls voltage given to the base. Okay. So let's see the right hand side. It is the positive is going through the LED, through the resistance, through the LED to the collector. Collector is connected to the emitter. Emitter is connected to the ground, and ground is connected back to the battery. So this part of the circuit is fine. And the left side of the circuit, which is the controlling circuit, the positive goes through the switch to this common terminal, goes to the base. So that means if I supply any current to the base, that base will open the gate and the collector emitter electricity will pass through and this LED is going to be switched on. Let's start the simulation and see what happens. Okay, it has blown. So if it has blown, Okay. First things first, the the base also requires less voltage. So let's give it less voltage. That means let's put in a resistance. Let me put make a copy of this resistance and let us have it something like this. All right. So I have the voltage to the base is also reduced using this particular resistance. All right. It has still blown. Yes, because this resistance is a little low. Let's make it 1 mega ohm resistance. Alright, it is still blown. Okay, I have changed the resistance over here to a 1 meg resistance and over here to 1k resistance to limit the electricity flow to the base. Alright, and when I switch it on, it is perfectly on. So let me switch this off. The switch, when the switch is off, the electricity that passes through this uh, becomes becomes zero. And although the light is being there is some glowing coming here, but the full current is not going through the correct collector and emitter. Okay, so you can see now that this is basically working like a switch, so like a an on-off kind of a switch. Let us use uh, an Arduino to do the same thing now. Okay, we use the physical switch. We are not going to use a physical switch now. We are going to use Arduino to do our task. That means I want the switch to be turned on and off uh, by for controlling the base. So what we need to do is we need an output from here. So output from here goes from pin number 2 maybe, and this is a digital out. So I've connected the digital out to this resistance which goes to the base. The right side remains the same. The ground is connected to the ground pin, and this is again connected to the ground pin there. So both the grounds are connected now. What else do I need? I need positive is now coming from the pin, and negative is coming from here, and I don't need anything else. Let's start the coding, and in the coding part, uh, let me have int base pin, which is equal to 2, and let me configure pin mode base pin as output pin. So I'll say base pin high and base pin low. So after a delay of 1000 milliseconds, the the base pin which was high, that means the electricity which was being passed to the base pin, which is pin number 2, which goes to the base of the transistor, um, that was going as high. Alright. Let's see now what things happens. Initializing on off perfectly. It is working perfectly fine. So now I'm not using a physical switch. I'm using Arduino to do the same task. Okay, now if Arduino is basically controlling this particular resistance as on and off, now please remember the voltage to the LED is not being supplied by the Arduino. Arduino can supply maximum 5 volts, and I want larger voltage. For example, here I am using 9 volt. and maybe I don't want to use an LED. I want to use a motor maybe. Let's use a motor. Let us use a DC motor. So DC. So let us use a DC motor, and connect the positive to this and negative to this. So both of them are connected. Let's see what happens now. On, off, on, off, on, off, and so on and so forth. So the motor is turned on and off, on and off, on and off by Arduino. But Arduino is not giving current of the voltage directly to the motor. It is basically controlling the collector emitter electricity. And how is that being done? By passing a 0 or a 1, a high or a low, to pin number 2. So the circuit basically said pass high to the base pin, that means pass a 5 volts. So when a 5 volt gets passed, what happens at the base is it allows the electricity to pass through, the motor gets switched on, otherwise it doesn't get switched on. So it gets switched on, right? Now I hope it is very clear to you now. What is a transistor? A transistor works like a gate kind of a thing, which can be turned on or off using the voltage at the base. Now the three points on a transistor are base, collector and emitter. In an NPN transistor, the base is always positive, the collector is always positive, emitter is always negative, connected to the negative. So we also learned how to use a transistor with current going to the base. We use the switch in the beginning, but a switch is a physical switch, so I have to switch it on and off, on and off, on and off. But if I want to do it programmatically, then this is the last one that we used. We used a circuit with an Arduino. An Arduino, on pin number 2, we are passing it a high and a low at an interval of 1 second. So when a high is passed to the base, the motor gets switched on. When a low is passed to the base, the motor gets switched on. Right? I hope this is clear to you. If you have any problem, please send me a message in the comment section. If you have any suggestions, please uh, write down the comments. Thank you. I'll see you in the next video.